Hey guys, welcome to Celestial Tutors. Today in this video we are going to work on chapter 1 Limits and Continuity of AP Calculus, and this is the second topic of this first chapter, finding limits using algebraic manipulations. And there are many ways to find limits using algebraic manipulations. First of them is by direct substitution. As the name indicates, we directly substitute the given limit as the x value into the given function and calculate whether it is a polynomial function or it is a rational function or it may be a radical function or exponential function. Sometimes you just plug in the given x value for the limit. When we plug in the given limit into this polynomial function, we get a finite value as the limit. So this is the answer. Next one is a rational function. Here too we just plug in the given limit as x tends to 0 for the x value and solve it. Again we get a finite value. By direct substitution we always get a finite value as the answer. Now this next one is a radical function, and here too we just plug in the given limit as x tends to 3 as the x value. That gives you square root 7 plus 2 square root 7. This is 1 square root 7 plus 2 square root 7. These are the like radicals, and we can always add or subtract the like radicals. To add them, we just add the front numbers, these ones. 1 plus 2 is 3, and keep the radical part as it is. So we get 3 square root 7 over 3, and at last we can cross out this 3, and the final answer is square root 7. So this way we can directly substitute the given limits into the different functions, and the answer is always a finite value. Now this is the next method, by factoring. Sometimes direct substitution doesn't work. If we plug in the direct limit as x equals 0, as you can see, direct substitution is not working here, because when we plug in x as 0, we get 0 over 0, which is indeterminate form. That means we have to simplify it some other way. So we can find out the factors of top and bottom and cross out those factors which are making it undefined. We can see that x square is a common term on the top and in the bottom as well. So we can pull out x square from the top and from the bottom as well. And then we can cross out those common factors x square and x square. Now you can plug in the given limit as x equals 0. And we get the final answer as negative 1 over 2. So this is a finite value, and this is the answer of this limit problem. For this next problem as well, if we directly substitute limit x as 1, we get indeterminate form. 1 minus 1 gives you 0 over 1 minus 1 is 0, which is again an indeterminate form. That means we have to simplify this expression using factoring techniques. We are supposed to be good with these factoring techniques, and here are some identities which are used for factoring. The first one is difference of squares, then difference of cubes, then sum of cubes. Here for the numerator we can use difference of cubes, because this 1 can be written as 1 cube, and we can see this is a difference of cube now. And we can apply the identity here. This common factor can be crossed out. After cancelling out the common factors from top and bottom, we get a simplified expression, and now we can plug in the given limit x as 1 into this expression. It's 1 squared plus 1 plus 1, that gives you 3. And we get a finite value for the given expression. And the next algebraic technique is by rationalizing. Sometimes we are given square roots or radicals in the given expression. In that case, we have to use rationalizing. We have to make the irrational expression as a rational one. That's why this process is called rationalizing, because we are making the irrational part as a rational one. Let's work on an example. If we plug in the limit x as 0 over here, we are going to get 1 minus 1 over 0, that gives you 0 over 0, the indeterminate form. It won't be an indeterminate form if there is plus 1 in the numerator. That means this numerator is making it undefined. So we have to simplify this expression by rationalizing the numerator. To rationalize this expression, we just multiply the top and bottom with its conjugate, the conjugate of this radical expression. To find the conjugate, we just change the middle sign. It is negative, we change it to positive, and it becomes square root x plus 1 plus 1. This is very important technique, and generally we are going to see one of these kind of problems in our AP Calculus exam. Now we just simplify it little more. Now we can see on the top there is an identity like a minus b times a plus b. So we can apply the identity which is difference of squares. A minus b times a plus b equals a squared minus b squared. So here we have a as square root x plus 1. So that becomes squared minus b is just 1 squared, and then the square root get eliminated with the square, and on the top we are left with x plus 1 minus 1 over x times the whole expression. Now this plus 1 and minus 1 get cancelled. On the top we are left with just x, and this is further get cross cancelled with x in the bottom. At last we write the simplified expression. This is the most simplified and reduced form. It can't be simplified or reduced any further. So now we can plug in the limit x is 0 into this expression, and we get a finite value as 1/2 as the limit. This is another example of rationalizing technique. Here we see that if we plug in the limit directly, x is -1, at last we get the indeterminate form. That means we have to simplify this expression using rationalizing technique, because this is having the square root part in it. To rationalize this expression, we just multiply the numerator and denominator with its conjugate. So what's the conjugate of this square root expression? We just change the middle sign as from negative to positive and multiply the top and bottom with its conjugate like this. Then we simplify it further. Now here we can see that this is an identity like a minus b times a plus b, so which is equal to a square minus b square, the difference of squares. So we are going to use the difference of squares identity for this expression. We have a as square root x square plus 8. So it would be a squared minus b is just 3 squared. So this was a squared minus b squared, the difference of squares identity. Now the square root get eliminated with the square, and we are left with just x square plus 8 on the top minus 3 square is 9. Then we write the whole expression in the bottom. After simplifying the top, we get x squared minus 1. This x squared minus 1 get factored into x plus 1 times x minus 1, because x squared minus 1 can be written as x squared minus 1 squared. This is same just as a square minus b square, and a square minus b square equals a plus b times a minus b. If we plug in the limit x is -1 into this step at this stage, it again gives us indeterminate form, because x square gives you -1 squared is again a positive, and 1 minus 1 gives you 0. So you are going to get 0 on the top, and this again x plus 1 becomes -1 plus 1. This again becomes 0. So 0 over 0 is again an indeterminate form. That means we have to remove this x square minus 1. We have to simplify it further. And here we simplify it further. And here we can cross out the common factor x plus 1. From top and bottom, we are left with simplified expression as x minus 1 on the top And now we can plug in the given limit x as -1. So we are going to replace x with -1 on the top and in the bottom as well. -1 squared is 1, 1 plus 8 is 9, and square root of 9 is 3. After simplifying it, we get -2/6, which gives us -1/3, which is a finite value, and this is the answer for the given limit problem. So in this video, we learned the three techniques of algebraic limits. First one was direct substitution, second by factoring, and third by rationalizing. In our next video, we are going to learn more algebraic techniques to find the limits. So stay tuned for next video. Till then, take care, bye bye, and don't forget to share, like and subscribe my channel. Thanks for watching.